Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 16th. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. Seas are south of the southern tip of South America, and we're never in the California or U.S. swell window, and for that matter, barely in the Chilean swell window. We also see some seas in the 24-foot range right south of Tasmania, but expected to fade before ever really getting cleanly into the Tasman Sea. Let's take a look at the details. First, we're going to take a look at jet stream level winds. These winds are really what help support the formation of storms, and when those storms do form, help direct their track. This is up about 30,000 feet. We're looking for troughs in the southern branch of the jet stream. That is, winds pushing to the north, forming a bow. That helps form clockwise circulation in the southern hemisphere, which is a signature of low pressure. We see a trough, sure enough, south of Tasmania, and as we saw in the previous chart, some sort of activity is going on here producing seas. But also notice just east of there, the jet dives south. The ice line is about 65, if not 63 to the north, and the jet basically dives south of that, so all storms would be south of that line, basically over Antarctic ice, or if not into Antarctica proper. Between the two is a big split between the northern branch and the southern branch. Typically high pressure forms in here. And this is the pattern that we've been seeing for the past couple of weeks. Not a whole lot going on in the southern hemisphere. A little bit of a trough is sort of here, and a little bit of trough is sort of here. That is pushing to the north just a little bit. And that helps support low pressure, and not in terms of swell production, but Tahiti's here. And what we're looking for is low pressure south of Tahiti, high pressure over eastern Australia. That helps drive the Southern Oscillation Index negative, and that is one of the hallmark atmospheric coupling signs of El Nino. We'll get more into that in a second. Anyway, let's just drive through this real quick because the pattern is basically a continuation of the same. A little bit of a trough here on, actually we'll go back Tuesday, Wednesday. Pretty good winds there, 140 knot winds pushing to the north. Low pressure, more than likely possible here south of New Zealand on late Tuesday into Wednesday. But that just as soon collapses, and then it's back to the same old thing, just this zone flat, well-displaced south flow, and whoops, there we go, and that is a little bit of a trough starting to show, but still not above the ice line, not pushing north of the ice line, and that's a week out. Let's go take a look down at the surface and see how this jet stream flow manifests there. And here we are, current surface level pressure, surface level winds, high pressure, not very strong, 10-20 millibars, but here, southeast of New Zealand, pushing south to about 62 south, and that's what's helping, at least at the surface, drive this the storm track way down here, and never getting the chance to push north. Also, another big high pressure system here off Chile, not pushing as far to the south, but still kind of blocking things off. And then here's cutoff low pressure well south of New Zealand, not doing anything for the Southern Oscillation Index. So here we go, we're into Monday, another low pressure here, cutoff low trying to form south of New Zealand, south of Tahiti, which will help drive the Southern Oscillation Index negative. But what we're really looking at is low pressure here, maybe come, here we go, Tuesday, 40 knot winds out of the southwest, just barely in the swell window for maybe the U.S. West Coast, and that continues into Wednesday, looking pretty solid. But notice here, high pressure, just look at the direction of the wind bar or wind arrows here, all into Antarctica. It is this area that could push generate some seas pushing north towards Tahiti, Hawaii, and the U.S. West Coast. But even by Wednesday, that's down to 30 knot winds. You need something more than that. Another little secondary fetch trying to get going here. Notice also by Thursday, this low looks pretty good south of Tahiti, right in this area. So that might help drive the SOI negative, as we said before. But then that moves out of the picture. High pressure here. We also actually, if you go back, you can see high pressure over southeast Australia. That is another thing that would drive the SOI negative. Anyway, roll this out. Not a whole lot going on. Another little low forecast here on 180 hours out. We saw a little kink in the jet there, but the ice line's right about here, so maybe only half that fetch is really exposed and able to get traction on ice-free waters. Let's go see what all this means in terms of sea generation. So here we are, current significant wave heights for the South Pacific Ocean, also the Northern Hemisphere, but we're going to talk about that separately, specifically in regards to these two systems here. But let's keep our eyes on the south end of the chart for now. We don't see anything really going on until, here we go, let's take it 12Z Tuesday. Let's do the Great Circle paths relative to Northern California. 221 degree track. This system with, what is that, 26, maybe 27 foot seas is in the swell window for Northern California. Relative to Hawaii, it is also in it, but coming through the Fiji Channel. Pretty well filtered there, and of course also in the window for Southern California. But with 28-foot seas and being, 6,500 nautical miles away, I mean, we could actually sort of figure it out here real quick. Let's just do it. Whoops, we lost it there. We'll do it one more time. Pull it on up there. What is that? Oh, I'm sorry, 7,400 nautical miles. Next to no swell will make it to the U.S. West Coast. Let's see what happens, though. As we go out here, it builds a little bit, and here we go. Now we're into Tuesday night, 30-foot seas. Yeah, right about there. It peaks out about 10 o'clock, 11 o'clock local time on the 218-degree track, unshadowed by Tahiti, good for both Northern California and Southern California. And just for laughs, let's see, none of that, unfortunately, is in the Hawaii swell window, shadowed by New Zealand. But, so, some swell, 30-foot seas, that'll get you, 32-foot seas, that'll get you about a 7, the most of the meat would be in probably the 16 or 17 second period zone. For Southern California, a little background swell, and certainly for Tahiti as well. Here we go, we got it right here. There's Tahiti. So, swell, for sure, nothing huge, but at least a little inkling of something. Anyway, let's keep rolling this out, see what happens after that. That system pretty much peters out, tries to organize a little bit here, but doesn't really do a whole lot, and that's pretty much the end of it, 180 hours out. So for right now, one small system possible Tuesday night. At least that's more than we've had. The Southern Hemisphere has just been dead flat, nothing going on. Split jet stream flow just taking over and just shutting it down completely. Let's go take a quick look at what's going on in the north. So here we are, North Pacific Ocean. We're back in time. We're back to almost a week ago, Monday night, the August 11th. What we're looking at is this system here, what was Tropical Storm Malave, and here's the point. Watch this. It recurved. It actually developed down here, recurved off of Japan, and started heading to the almost due east, 20-foot seas. It got a little bit, maybe 22-foot seas, and then built a little bit per the model. And here's the interesting part. Relative to Hawaii, look at this. Seas, there's the 305-degree Great Circle track, and 23, 24-foot seas here, and then faded out, pushing up, let's say, the 305 to 308-degree tracks to Hawaii. Some tiny small swell might result. Now, relative to Northern California, we can take a look, too. It's actually tracking much better, but so far away, this is over 3,000 nautical miles from California, when this system could only generate maybe a 13 or 14 second period swell, and maybe just a couple feet at that. Probably will not be noticeable in California at all, but tiny swell maybe for Hawaii. And now here we go, the current charts, and there's two systems, two tropical systems. The first one, Gani. I think we're saying that right. The one behind it, at Sani. So let's go into the details. Just a quick look here at Gani. And of course what we're looking for is the storm to track to the northeast to try to generate swell relative to Hawaii and the U.S. West Coast. We don't see that. We see a track currently basically heading west-northwest. Winds, the system is to build. Currently it's got 80-knot winds, forecast to go to 130 knots on the 19th, just southeast here of Taiwan. Current satellite image, pretty solid. Look at that. It's actually got an eye. Typically, you don't see an eye till you're in the 85 to 90 knot range minimum. Pretty good organization. This system is looking fairly powerful so far and expected to strengthen. But again, relative to our interest in terms of generating surf, none is expected unless by some miracle it recurved here, but we're not seeing that on the models. On the next system at Sani, Little bit more interesting, not so great here looking on the chart and looking at the satellite image. It's not a very strong system. 65 knot winds, forecast to go to 125 knots on the 20th, right up in this region, well southeast of Japan. But take a look at this. Here we go, surface level pressure and winds. Watch the second system here. This is our target. We're just going to roll this out. Now watch this track. It actually was to recurve earlier runs right here on the 150 line. It's now forecast to make it further to the west, but then starting to recurve. The question is, what does it do from this point here? We've actually got access to 2-week models, and they suggested it's going to do the full recurvature and go extratropical and make it to somewhere around the dateline region. How strong, no one knows. Let's take a look, though, real quick at this. Here we go. Here's the actual significant wave height charts. Here's our system. We're watching sea heights here, 52, 54, 51 foot seas, hanging in there. This is just focused on this system right here, 54 foot seas to, and then 59 foot seas. Now, clearly we are hyping this. Don't believe a word of this. Tropical systems do not do what they're supposed to do in the time frame they're supposed to do, especially by these what we'll call lower res models that are using like a half a degree resolution or quarter degree resolution. But we'll see. These models have done not a horrible job so far this year. We're a week out. The recurvature thing isn't even supposed to happen till after a week out, so it's all just fantasy land. But significant sea generation possible, certainly aimed at Japan if this thing were to recurve, and there is some reasonable possibility based on long-range models that it would do just exactly that. So we'll see. Something to tease yourself with. Don't bet on it, though. Likewise, there's also another tropical system not even really getting organized till Friday, so this is not believable, tracking south of Hawaii. Pretty decent-sized seas, but the question being, what is it going to do? Will it in turn get sucked to the north? Let's take a look at the jet stream and see if it gives us any clues. So here's the North Pacific jet stream, looking not very particularly impressive at all. The most of the energy's up here in the northern branch, up around 55, maybe dipping down to 50. Not very energetic. And the reality is here's a little bit of a split, and this is where things get interesting as we get out in time, because that builds a little bit, and this southern branch is what would catch these tropical systems. In fact, there you go. Let's see how much of that. You can see both of them clearly identified here, even up at 30,000 plus feet, and certainly the jet stream could have some impact. And here we go, 180 hours out. Look at this, the jet actually is diving pretty far to the south and getting kind of healthy looking for mid to late August. Not too bad, pretty good ridge here pushing south, and then a big trough here in the western Gulf of Alaska. So this is what would help redirect the second system to the east if it were to happen. Again, this is all fantasy land, something to monitor, but there's a lot of hype about it. You'll probably see it as you're perusing the web. Just keep in mind that it's all fantasy land a week out, but worth monitoring. So let's start talking real long-term outlets. Let's start talking El Nino. Everyone's talking about it, lots of hype on the web, so let's get into some of the details. Let's try to take some of the mystery of what's going on and get closer to the truth on what is actually happening. El Nino is defined by warm water building up in this area, basically between Ecuador and the dateline, but specifically the region they call the Nino 3.4 region, between 170 and 120, and a couple of degrees either side of the equator. Draw a box right here. If you have warm water here, and it's if it's half a degree above normal for a couple of months, that is El Nino. If it's 1 degree above normal, then you're into a moderate plus El Nino. If it's 1.5 degrees above normal, then you're into a strong El Nino. Looking at the current average of all the water in the Nino 3.4 region, we are currently seeing the temperature at plus 1.889, plus 1.9 degrees, almost 2 degrees above normal for this time of year. Again, 1.5 degrees and above is considered a strong El Nino. We're well past that category already. So the hype would be, we have a massive El Nino. It's coming our way. the sky is falling. And it is true, things are very strong right now, but we need to understand what's coming in for the future and what has happened in the past to try to put this in perspective. We still have a ways to go. We need this these water temperatures to last into the December, if not January time frame, if you're really going to have a really strong El Nino. Having this warmer water right now is great. Drives the atmosphere nuts and helps build a stronger bond between the water temperatures at the surface and what's happening in the jet stream and everything else to try to set us up for the big, fabled winter mad El Nino season. Again, El Nino doesn't do a whole lot this time of year. It's in the fall and the winter months that it really has its biggest impact. So, here's our current water temperatures. Looks pretty impressive. Not great, but pretty impressive. Now let's go back to the middle of July. Water temperatures were warmer, more consolidated, definitely more focused here in the Nino 1.2 region, just off Ecuador near the Galapagos. And what has been happening is that warm water has been working its way here, okay, to the west, advecting to the west, driven by trade winds in this area. Okay, but notice what's happening here. Water temperatures are nowhere near as warm or as concentrated as they were back in July. So what's that all mean? Well, in July, the first and the second of two solid Kelvin waves, that is warm water, and let's give the quick overview here. West wind anomalies start blowing in this region. In March they did, and then again, let's say the March time frame all the way into almost June. That created warm water that was here, gets transported to depth in a thing they call a Kelvin wave. It's a pocket of warm water, travels the whole way across the Pacific, erupts along the Ecuador coast, and creates a warm pool here. Trades catch that, and trades blowing out of the east, take that warm water and start transporting it here. And what that does is it starts impacting the atmosphere above it, changing a thing called the Walker circulation. We're not going to get into that. There's plenty of this on the web. You can go dig it up and look. Just Google Walker circulation. But it starts basically changing the upper and lower atmospheric circulation in this area, which has significant consequences for the North Pacific in the winter. Okay? So anyway, warm water here starts changing the atmosphere. But what we're seeing now is that warm water, yes, it's moving off here, but falling apart here. So let's get into just dissecting that for a second. So here we go. Here's Ecuador here, Galapagos Islands here. This is July 14th, about the same time we looked at those when max heating was going on in this region. You see clearly 4 degree, here's our scale, 4 degree or greater anomalies in pockets in this area. Water temperatures are very warm. We'll get into all the details here in a second. And then what happened? We go to August 10th. Still there's warm water, but not looking not looking nearly as robust as it was. This was at the peak of the Kelvin wave eruption here in July. Things moderated into August, and now here we are, current, boom. In 3 days, it went from that, in 6 days, from that to that, and all of a sudden, all the warm water started evaporating. Now, we're not saying this is the end of the world by any stretch, but we're just trying to paint a picture here in that there was very warm water here. And remember, we say trades blow. Okay, well, this cooler water at some point is going to start going off to the east. Okay, so now we go off to, let's say, we'll call this roughly the heart of the Kelvin wave. I mean, not the Nino 3.4 region. 160, actually, it goes over to 170, 120. Draw a box right in here. This is the area you're looking at. Now, this was the peak, July 14th, of the Kelvin wave erupting off of Ecuador, and you see warm water working its way to the west, but not quite getting there. Now, currently, here's the current image. Boom, lots of great warm water in there. This is what is driving the Nino 3.4 temperatures that we saw up into the 1.8, 1.9 degree range, making everyone go, yes, there's a huge El Nino happening. Absolutely, very solid, impressive indeed. But remember, if these warm waters were back here a month and a half ago and they advected over here, well, now we've got cooler water, not cold water, not cooler than normal water, just a lot less temperatures. That's going to work its way into this region at some point, and the high temperatures that are being experienced here are going to drop off. Does that mean that El Nino is in demise? Absolutely not. Let's get into a little more of the details. But first, a couple more data points. Just to drive the point home, average water temperatures in the Nino 1.2 region, you can see they spiked, here we go, in the mid-July time frame, 3 degrees above normal there between Ecuador and the Galapagos, and then see the steady fade, and now we're down to 1.5 degrees. Still, 1.5 degree temperatures is strong El Nino. We're in the Nino 1.2 region, but it is a drop off from the peaks. So again, just another illustration of what we've seen in the previous images. And yet one more, this is what we call a virtual station data. So assume that there's a buoy sitting over the Galapagos Islands measuring water temperatures. And we're looking down this column here. And here we go. July 17th, peak temperatures occurred there, 4.9 degrees. And then since then, look at these 4.9 degrees above normal. Since then, those temperatures have slowly faded into the 2.5 degree range. Today it's 2.1, but the reality is this station is actually west of where those lowest temperatures are occurring, right along the Ecuador coast. So we expect this to go down to maybe even 1.6 or 1.7 at some point, maybe 2 weeks out from now. And again, the cooler water is going to work its way west towards the Nino 3.4 region and have an impact there for sure. And yet one more view. These are sea surface temperature anomaly differences in normal for this time of year. These locations, you can see these pulses of very warm water working their way into the Nino 3.4 region here. You can see not as much warm water here. In fact, we used to see these pulses all bundled up right along here. So they're just doing their thing. They're following the conveyor belt off to the west. This is a nice view here because it shows the differences in sea surface temperatures in just the past week. Clearly the blues are cooler than what was there a week ago, and clearly you can see the cool pocket starting to work its way off to the west, where here it's still warming. See, south of Hawaii, in fact, right in here, here's your Nino 3.4 region. Peak water temperatures from the first Kelvin wave and parts of the second Kelvin wave are inflowing here and driving the numbers very high. And then again, back to our current sea surface temperature anomaly chart compared to the epic El Nino of 97 in this time frame, in the mid-August time frame. Here we go. Look at that. There is really no comparison. We kind of beat this one to death, but just to put things in perspective, the 97 El Nino was the strongest ever. At this time of the year, clearly a major footprint, major warm water. Where we are doesn't even come close, but it is still solid. So does this mean that El Nino is fading? That it's all over? Absolutely not. So what are we looking here? Sea level anomalies. From the Jason 2 satellite, you basically map out the height of the ocean compared to normal, strip out all the waves, the tides, every little variation, and what we're looking for is above normal sea heights. And what does that mean? That means that at depth, we talked about Kelvin waves, right? Kelvin waves move from west to east, pockets of warm water. If you have warm water at depth, what it does, because it's relatively more warm water expands effectively, it causes the surface to rise. And what we see in this picture here is a massive Kelvin wave working its way to the east. Okay? So basically filling the entire region from the date line almost, here's the Galapagos, and notice here, just this one little patch not affected by the incoming, okay, we'll just say it, a large, massive Kelvin wave working its way to the east. So this is really pretty typical. What we're going to see here is between Kelvin waves, you get this thing called the upwelling phase. Temperatures back off here. You get a big rise. So the Kelvin wave comes in, lots of warm water builds up here. It vecks off to the west. The next Kelvin wave comes. You get a break. You get this little bit of upwelling of cooler water, and then the next one comes in. So what does this mean? Well, it means there's a lot more warm water coming, and this little pause that we're going through, we'll call it the upwelling phase. We didn't even want to go that far. We really wanted, our tendency and our official forecasts have just been calling it a pause, but I think it's pretty suffice to say now that it is, in fact, an upwelling phase of the Kelvin wave cycle. A little bit of a break, but we're not too disturbed about any of that. Let's get into the detail. So again, West Pacific is here. East Pacific is here. These little X's coming down are buoys, the TAO buoy array. Sensors on the buoys. Notice there's some sensors out here. This whole array out here is out. But still, you get a pretty good sense of what's going on. And what is really noticeable here in this image, this is actual water temperatures. 29 degrees, 30 degrees centigrade, very warm. A large pocket of warm water here is working its way off to the east. Here's deviations from normal for this time of year, and you see 6. This was actually right in here at 7 degrees above normal. That is very warm, very solid indeed. And these warm anomalies continue solid out to 150 west. So there's a large Kelvin wave in the pipe working its way towards the Galapagos, just like we saw in the previous image. And here's yet another view of it. Now, this is the interesting part here, here's the Kelvin wave, and let's see if we can do this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 6 degrees plus it's saying here. Also notice this. Look at this. The little pocket here. The last little, we're actually calling it a backdraft because this has gotten stronger. It's as this Kelvin wave gets bigger, it's almost like sucking any warm water that's in this region backwards, and, to backfill. And what you end up is a bit of a void here. And then it works its way up to the surface before this guy comes rolling in. And it is coming. The other thing you want to notice here is there's been west anomalies blowing nonstop still to date over here in the West Pacific, pushing more warm water to depth. So this thing is still growing. So here's another way to look at it. This is total upper ocean heat content. West Pacific over here, East Pacific over here. We're into September, October last year. 2 Kelvin waves, 1 Kelvin wave, the warm water working its way, and we go in time as we go down here. So you can see a Kelvin wave working its way to the east, another one working its way. Here's your upwelling phase, cool water, and then here's the Kelvin wave from March, and it got very warm here right before it erupted in the May time frame. That is part of the warm water that is over in the Nino 3.4 region now, making those record warm temperatures. Another Kelvin wave in the May time frame pushed east, but here is the really interesting one. This is from a massive westerly wind burst that occurred late in June. Almost all of July has been blowing nonstop. It's backed off a little bit lately, but still very strong westerly winds. Look at this. Compared to anything this year, we thought that was really warm. That was very impressive. Look at this. This just dwarfs that like nothing. Plus 2.5 degrees over a large area. And just since the last reading, you can see it's expanded this way and this way. So this thing isn't done growing yet. And then here again, here's that pocket of cooler water. When we say cooler water, we're talking a half to 1 degree above normal, which any other time, if you saw that warm water like that gurgling up off the Galapagos, especially after the past 4 or 5 years, we'd be kind of excited going, oh man, that looks pretty impressive. Well, look what's coming. Nothing. So the point being here is, yes, water is cooling off the Galapagos a little bit. It's still above normal, and we expect it to continue to do that for a week or two. It's hard to say. We ran some calculations trying to figure out how soon this would actually make its way. And you notice, look at this, it's like a straight wall. It just hasn't, warm water hasn't pushed through and started working its way to the east yet. But when this guy comes, it's going to be significant. But the point being, the cool water that's off of Ecuador right now is going to go in, take a hit when it moves into the Nino 3.4 region. Temps are going to back off, but then this guy's going to come and warm them right up again. And so this guy, we would expect it's going to be a couple of months at least until it makes it into the Nino 3.4 region. I mean, it'll probably be a month till this guy. So we're talking mid-September roughly till the peak of this starts working. It's maybe even longer. And then another month to probably. So we're in October, November time frame. So this basically sets you up for a significant El Nino right here. And then that still doesn't talk about the question of, are there more westerly winds blowing? Will yet another Kelvin wave result? Let's see if we can get some insight into that. So here we are. In the what we're looking for is westerly winds, and we actually see them here. So there's an area called the Kelvin wave generation area. Actually, that's our acronym. Anyway, it runs from about 135 to about 170. If you have westerly winds in this area and just a couple of degrees either side of the equator, that helps create a Kelvin wave. Well, we see south winds, but we also see some westerly winds. They've been blowing much harder for days. This is the weakest they've been so far. But here's actual anomalies. So this is actual winds. All you need is a slackening of the trades to get anomalies, and they're still blowing here, basically on the date line and west of the date line. So this is continuing to help push warm water down into our developing Kelvin wave. And of course, here we see the warm anomalies coming from the Galapagos off to the west. Here's a better way to look at it. These are anomalies, 850 millibar vector wind anomalies. That's up about 4,500 feet, but is a good proxy for what's going on down at the surface. And this is starting August 10th, and you can just see westerly anomalies. They continue, and then they're starting to fade here per the August 14th image. We're also looking for southerly winds along the coast of Australia. Not seeing it so much. This is theorized to help a thing called the Southern Hemi Booster Index. More south and southeast winds here. What you get is the winds actually come up here, and then they make the turn, and they blow this way. We're actually looking for some of that, and you see it more here doing that sort of a thing. So during super El Ninos, the noticeable component is the southerly winds along the coast of Australia and southeast winds. So we're seeing some of that, but not a lot the past couple of days. And again, another view. So the West Pacific is here, East Pacific is here. Time goes down the chart. Oranges, reds are westerly anomalies. Blue are easterlies anomalies. So here we are in the July time frame. Massive westerly wind bursts just going on and on and on. Here we are right now. Things are starting to fade out a little bit. Still much westerly winds. This is the big the tail end. This is actually like a mini westerly wind burst. The major part of this westerly wind burst started in the end of June, and this is what generated the massive Kelvin wave that is pushing east now. So the question is, what's coming for the future? Well, here we are, and then we see, at least per this chart, weak easterly anomalies just over part of the Kelvin wave generation area, maybe, and up at 850 millibars, a lot of times this turns out to just be dead slack winds. But westerly anomalies are still expected to hold from the date line east, and there's only about 10 or 15 degrees off to about, let's say, 170, 165, where westerly anomalies continue to feed the existing Kelvin wave. But then that sort of retrogrades about a week out, and things are supposed to getting a little bit better. Now again, here's this busy chart that we've shown in the past, but it's a great chart because it really ties everything together. The MJO, inactive phase of the MJO in the June time frame, and the reds you're looking for are westerly anomalies. A little bit of a Kelvin wave going on here, atmospheric Kelvin wave, created some westerly anomalies, but it was here in the late June time frame the MJO went active, and not only that, we had equatorial Rossby waves interfering in a positive way with that, just super amplifying westerly winds. This is really what generated the Kelvin wave. But then we had another equatorial Rossby wave come in here and also help push it, and yet another pulse of one here right in current time, another westerly wind burst. So here we are now in sort of a slack phase, and you can also see all the tropical activity that was spurred as a result of either the MJO or or an El Nino base state interacting with these Rossby waves. Now here we go, we're in like a down phase of the Rossby wave cycle. Here's that little pocket of lack of westerly winds. This says no easterly winds. This just basically says kind of dead neutral. But we're not too far out here. By the time we get, per this chart, what is that? The 20th or so, then we start seeing stronger westerly anomalies, and then the train just starts starts rolling for the next month from there. Also notice these gray lines. This is the El Nino base state, and it was kind of weak there, but notice these contours start getting more concentrated as we get in the August time frame, suggesting that the base state gets even more defined. The stronger the El Nino base state becomes, the less we have to worry about the MJO or Rossby waves to generate westerly winds. It takes on a life of its own and then just self-perpetuates westerly anomalies. The point being, we're looking for yet another Kelvin wave, preferably a strong one, to develop behind the big Kelvin wave that's poised to erupt within the next month along Ecuador. So here's another flavor of the chart, only this one's in reverse. Here's the past down here, April, and it's going in time up this way. Has a longer forecast window, and again, the region we're looking at is the Kelvin wave generation area, going roughly from, we'll say, 130-ish right up here to about 170 right here. Now, clearly we see a westerly wind burst in May, a stronger one in the late June, July time frame, these little pulses that have just occurred, and then here we go. This little pocket right here, I mean, just a tiny little pocket. This is our little pause that we're expecting for maybe a week or so. And then notice, and again, earlier we were talking about, I don't believe a model a week out. Well, here's a model that goes August, September, October, 3 months out, but it suggests, notice this, just a continue building of westerly anomalies into November. If this were to occur, that would be extremely good. Let's sort of say, okay, now how does the MJO impact this? Well, here we go. Okay, so we're kind of in an inactive MJO steer. The dotted red lines are inactive MJO. It's sort of showing an MJO here, but that's really more of a filtering thing. This is what a real MJO looks like. And look at this. A real MJO interfering with an El Nino base state is projected in the, let's say, in late part of September all the way into November. And then you get some Kelvin wave, I'm sorry, we don't want Kelvin, we want Rossby wave interaction too. So we see some here, and some here too, and some here. So basically there's some interaction going on, and of course we can take that out and just do the low pass too. And here you go, here's your El Nino building base state. So just building. So let's just say, what if this active MJO signal happen? These westerly wind bursts happen in October. So we have a huge Kelvin wave right now that's poised to impact on the coast. And if we got this in the October time frame, let's say, 3 months after that, October to November, December, January, you would have yet another large Kelvin wave coming in January. Okay? So the point is, where would the peak of El Nino be? The 97 El Nino peaked early. That was a super El Nino, strongest ever. We're talking November time frame. The 82-83 El Nino was a late bloomer. It wasn't even, and it was the second strongest El Nino ever. It wasn't even getting its act together, just starting about this time of year, and it peaked in the January-February time frame. So, and the point being, the longer it takes for El Nino to get going, the longer it keeps churning and trying to pound, affect the atmosphere, the longer it holds together, the longer it'll take for it to die. At least that's our assumption, which means that we could have impacts well into next, not the winter of 2015, 2016, but maybe 2016, 2017, if this peaks out in, let's say, the January, February time frame. But again, this is a model going 3 months out, worth nothing, but it paints an interesting picture. Let's go take a look at something else. So how coupled is the atmosphere with the ocean at this point in time? The Southern Oscillation Index, we've talked about this a little bit, difference in pressure between Darwin and Tahiti helps give us a clue. Daily numbers, long-running negative numbers, the more negative the better, suggests a very strong coupling with the atmosphere. We've gone through this great run here. Actually, it started, let's say the end of July, and for the whole month we have good 20, 30 below normal, and here we are today, minus 31.7. The 30-day running average is minus 18.55. What we like to use is anything below about minus 15 is a sign of a well-coupled El Nino atmospheric interaction. But what we really want to see is those minus 15s to minus 18s in the 90-day running average here. Right now, it's at about minus 12, which is quite respectable. But again, we're very early in the cycle. This is the August time frame. El Nino typically doesn't really start doing its thing. If we want to see minus 15s to 18s over here, we wouldn't expect to see those until October, November time frame, or even later. So actually, we're in a very good place per this. Graphically, here's a way to look at the 30-day, not the 90-day, the 30-day SOI average. Again, back in 2013, 2014, we were up in positive territory. Things started here. This was the false start El Nino of 2014. It kind of rebounded. Then in mid of 2014, we started going into negative territory. We've stayed there ever since. Notice this. Yeah, we've had some spikes up to 0, but the reality is we're down here. Here is the peak lowest of the low that was like minus 21 or 22. In the big, massive active phase of the MJO back then, and we are right on the cusp of being there yet again. This is good news. Next, the ESPI index, okay, and what it's measuring, since we got great high-res satellite data, it basically says, it's sort of like the SOI, tell me the rainfall amounts in this area versus this area and build an index out of it, okay? And here's the actual anomalies. Rain here, notice a lack of rain here, and crunch it into an index. The current number is 2.59. To put that in perspective, the 83 El Nino was, at its peak, was roughly a 2.3. The 97 El Nino at its peak was a 2.8. Now, the graph hasn't been updated here, but we saw the number, 2.59. Per this index, we are already past the 82-83 El Nino in the approaching 97 range, and it's been holding in this 2.59 for about a week or so. We haven't been following this index, but for a very short period of time, so we don't have a pedigree, personal experience with it. But the numbers just out of the box suggest that something very significant is going on, and that there is a strong coupling in the atmosphere already, and that's being manifest by precipitation anomalies. Okay, but the precipitation anomalies we assume are being driven by the temperature anomalies in this region. If the temperature anomalies here, which are less ocean surface temperature anomalies, start working their way west, that'll probably take a hit on the ESPI at some point. But again, another Kelvin wave in the pipe, water temperatures will warm back up, probably these temperatures, this index will reflect that accordingly. And then finally, the multivariable ENSO index, multiple things put together. This hasn't changed since the last report. They only update it once a month. It was the 4th of August. But again, this one suggests this is the 97 El Nino up here. The green is the 82-83 El Nino. Notice the peaks here too. The 97 peaked out per this index early on in the September time frame, and then did another peak in the, let's say, the February time frame, whereas the 82-83 El Nino was on a steady climb, peaked in the let's say March time frame. What we're going to do here, hard to say, but at this point in time, looks like it's somewhere between the two, the 82-83 and the 97 El Nino, and we still have a long ways to go. So finally, sea surface temperature forecast for the Nino 3.4 region per the CFS version 2, uncorrected. This says 3-degree anomaly temperatures in the, let's say, November time frame. Corrected temperatures normalized 2-degree. We suspect that's a little on the low side. We suspect the temperatures on the previous chart are a little on the high side. Somewhere in the 2.2, 2.3 range would be probably appropriate, and that certainly puts this El Nino, if it develops as forecast, in line with a little bit above the 82-83 El Nino, which was a super El Nino, one of only two so far in, two so far in this century. So, what does all this mean? So we'll put a bow on it real quick. It's simple. A little bit of cooling right now. Temperatures in the Nino 3.4 region will take a hit. They are very high right now and of cause for concern. And rightfully so. But they will take a hit, moderate some, but a massive Kelvin wave, stronger than any of the Kelvin waves so far this year, is en route and will only serve long term to probably push those temperatures up as high as anything we're seeing right now, if not higher. And then if you start looking at the forecast charts, there's the possibility that there could be yet another Kelvin wave behind that. But that is very iffy at this point in time. So suffice it to say, very strong El Nino in development at this moment, with more coming behind it. We're waiting for the atmosphere to fully start supercharging, but typhoons in the West Pacific developing, forecast to recurve, already a small one, Malawi, already recurved, tiny swell for Hawaii expected, maybe much more coming in the week or 2 weeks ahead, and in the meantime, maybe a small little southern hemipulse to fill in the gaps. So for now, we're in the dead zone, the fall dead zone, or the pre-end of summer dead zone, waiting for fall to kick in, waiting for things to really start kicking off. But atmospherically, it looks like we are quite well primed, and that El Nino is chugging along at a very good pace, sort of halting. It goes, it stops, it goes, it halts, but it has good legs. It's been going here, building for 2 years. So historically, this is a significant event. Get ready for this winter. Do not dawdle. Do not wait to start your training regime, getting your boards, doing whatever you're going to do. If you're going to surf big waves, this is a winter to do it. So that's it for this week. We'll do this again next week. Same time, same channel. In the meantime, go get some wind swell or whatever you can. Stay in shape because it looks like things are getting ready to roar. Thank you.